In the transportation and logistics industry, unplanned equipment failures can lead to significant operational disruptions and increased costs. Traditional maintenance strategies are no longer sufficient. The solution? AI-driven predictive maintenance. This approach utilizes advanced analytics to monitor conditions in real time, helping organizations transition from reactive repairs to proactive maintenance. Predictive maintenance begins with understanding asset inventory and criticality assessment. It's crucial to identify key components and evaluate their impact on operations. Next, a robust sensor infrastructure is designed and deployed, ensuring effective data acquisition and edge processing. This includes capturing essential data like vibration and temperature, which is transmitted to centralized systems for further analysis. The integration of data from various sources allows for comprehensive visibility into asset health. Data quality management is essential at this stage to eliminate any inconsistencies that could impact decision-making. Feature engineering transforms raw data into valuable insights, which are then used to develop predictive models that forecast potential failures and estimate remaining useful life. Once models are validated, they are deployed in real-time systems where they process live data streams. This enables immediate alerts and automated workflows, making it easier for maintenance teams to act swiftly on critical predictions. An alerting system prioritizes notifications based on severity, ensuring that the most important issues receive attention promptly. Automated maintenance orchestration optimizes task scheduling and coordination of maintenance resources. This ensures that the right technicians are assigned to the right tasks at the right time. It aligns maintenance actions with operational needs, while also meeting compliance and safety regulations. Finally, a performance feedback loop captures post-maintenance outcomes, providing valuable data for continuous improvement. This data informs future predictive models, enhances workflow efficiencies, and ultimately leads to better asset longevity and reduced operational costs. In summary, AI-driven predictive maintenance in transportation and logistics encompasses a comprehensive workflow that integrates data acquisition, model development, real-time monitoring, and continuous improvement. This end-to-end approach ensures organizations can achieve operational excellence, minimize downtime, and maximize assets' reliability and efficiency. Now, explore how to implement these steps in your operations for optimized maintenance strategies by visiting the Augvation web store for more resources.